All right, so far we've talked about how level detectors work, and we've talked about how we sense level, how we can look at some basic units. Another thing we're going to talk about today is the forms of energy that we really need to know about, especially when we think about our cycle. Here's a turbine, reactor, condenser, and a pump. I mean, what types of energy are we actually using in our steam cycle here? So we're going to really look at 4 different types of energy. Energy is defined as the ability to do work. And there's lots of different types of energy. There's thermal energy. There's the chemical energy of a battery. There's the potential nuclear energy of a fuel pellet. But we're going to look at 4 types of energy and see how they can be, see if we're using those 4 types of energy in our cycle. So on your student guide, you'll see section 4.1 is energy. And we're going to look at 4 types. One is potential energy. Excuse me. The other is kinetic energy. Another is internal energy. And another one is flow. I have a flowing fluid. It can do work. Energy is the ability to do work. This is going to be flow energy. So these are 4 types that we're going to look at. And we are going to look at thermal energy and stuff, but this is real important. We're going to have to explain the relationship. Look, we have a knowledge requirement. We've got to explain the relationship between work, power, and energy. Well, the first one is energy has the ability to do work. It has that potential to do work. That's what energy is. Excuse me. Once again, if you turn the page, it shows us different types of energy and equations for them. For us, the first one we talk about is potential energy. And it's equal to mass times the acceleration due to gravity times height divided by the gravitational constant. So essentially, potential energy is equal to mass and height. So we don't extract this energy out of our working fluid in a nuclear reactor. This is how a dam converts energy. It takes the difference in height between one side of the dam and the other and uses that potential energy to convert it to kinetic energy as it comes down its penstocks towards its turbine. Then it causes rotational energy in the turbine. So we're going to know this one. Potential energy is due to height. And we know its equation. More importantly, we're going to know that Z, when we see it, is always height. And as Z is coming down, potential energy is coming down.